Net ionic equations. In a precipitation reaction, the ions that comprise a soluble ionic compound separate when they dissolve in water. So if we have salt here, which we're showing as an aqueous compound, and silver nitrate, aqueous, they will actually form silver chloride, which is a solid, and in another aqueous solution of sodium nitrate. Now, to write that in ionic form, we talked about how the ions disassemble, they separate. So this sodium chloride can be written like this. It's a collection of sodium and chlorine ions. Silver nitrate disassembles as such. Silver chloride, since it's a solid, is not dissolved, so that stays whole just like that. And then we have the sodium nitrate here that disassembles into its ions right there. Ions that are not involved in the reaction, which means they're not involved in the formation of the precipitate or solid, are called spectator ions. And they can be eliminated from the chemical equation. They play no significant roles, so that's why we're just getting rid of them. Reactions written in this way are called net ionic equations. So you saw on the previous page, right, we had this whole formula here. That's the complete ionic equation. And then when we get rid of the spectator ions, the only thing that's really going on here is silver is combining with chlorine to make silver chloride, which is a precipitate and a solid. A quick review: the complete ionic equation, that's the first thing we showed, that shows all aqueous substances, strong acids, strong bases, and soluble ionic compounds disassociated into their ions, like this. Sodium chloride splits into sodium ions and chlorine atoms. All ionic compounds, if they're soluble in water, will readily dissociate into the corresponding positive and minus ions. And we're kind of showing that over there. Let's show another example. Here we have silver nitrate, which is an aqueous solution. It's in the solution. Here's potassium chloride. And when they react, you will get a precipitate, a solid, silver chloride, and potassium nitrate, which is still in solution. When we want to show this as a complete ionic equation, that's this right here. Now, can you see somebody who is not disassembled into its respective ions? Yep, right here, the precipitate. This is coming out of solution and forming a solid. As this example shows, certain ions are present both before and after the reaction. They are not directly involved in reaction, and they are called the spectator ions. In this case, the potassium and the nitrate ions are spectator ions. And a cute way of looking at this is if you're doing math and you have the same number on either side of the equal sign, you just cancel them out. Same type of concept works here. Summarizing, the net ionic equation, right here, is an equation for a reaction in solution that only shows the particles that are directly involved in the chemical change. We start with the complete ionic equation, which shows all the compounds disassociated into their ionic form, and you cross out anything that does not change from the left side of the equation to the right. So you're canceling like terms, right? There's the nitrate, same on both sides. Potassium, same on both sides. So you're left with silver, chlorine, and then silver chloride. So after we cancel out the spectator ions, the only thing we're left with are those things that change or react during the course of the reaction. This is the net ionic equation. And we have a step-by-step process for this. First, write a balanced molecular equation. Second, disassociate any reactants or products that are aqueous. So that works for both the left and right hand side of the equation. All solids, liquids, and gases stay intact and do not disassociate. This is the complete ionic equation. Now we cross out anything that remains unchanged from the left side to the right side of the equation. And what do you think we're going to wind up with? Yep, the net ionic equation. So we have three things here: a balanced molecular equation, which leads to a complete ionic equation, and then finally the net ionic equation. Here's a worked out example. We have lead nitrate plus potassium iodide, both in aqueous solution, turns into lead iodide, which is the precipitate, that's a solid, and then we have this aqueous solution here, potassium nitrate. So the first thing we do is take anybody who's aqueous, and that's everybody except here, and disassociate them. So we have the lead ion, 2 nitrate ions. Notice we had 2 up here, so that 2 comes down to there. 2 Ks, aqueous, so we have 2K, and we also have 2I. The lead iodide comes down like it is because it's solid, and then here is what potassium nitrate goes into. And now the fun part, we cross out like items on the left and right. So 1 nitrate is there, potassium's here, and then what we have left is our net ionic equation. Your turn now. Either at your desk with a piece of paper or on the smart board. Practice writing a balanced equation. We're going to do 2 of these. And I'm going to want a balanced equation, a complete ionic equation, and a net ionic equation for the reaction right here. Okay, calcium nitrate plus potassium carbonate. So go ahead and pause this video and try working it out. Remember, we're going to want 3 equations. Okay, if you've unpaused now, let's take out the answer tab and see what we have. We have our balanced equation on top. Hang on, let me erase some of that stuff. Okay. Our balanced equation, making sure you have as many potassiums on the left as you do on the right, and carbons and oxygens. And here's our aqueous solutions. They're going to form a precipitate, calcium carbonate, which is a solid, and then another aqueous, potassium nitrate. So that's our first step. Second, we want the complete ionic equation, and that's over here. I've got it in 2 lines. We've got the products up here and a reactants on the second, just so it fits here. Notice we've disassembled everybody except for the calcium carbonate. Then we're going to cross out like items. So here's 2 nitrates, gets rid of that. 2 potassiums, get rid of that. And we're left with calcium and carbonate on the left and calcium carbonate on the right. And this is our net ionic equation. Here's another equation, and feel free to consult your periodic table to get the valences of the various elements and the nitrate and the phosphate. And put together first a balanced equation, then the complete ionic equation, and then the net ionic equation. So please pause the video, give it a shot, and when you're ready, unpause and come back. Okay, hopefully you've given this a shot, and let's see what we get. So here's our balanced equation. Again, using the periodic table to get valences where we needed it. And then we will disassociate this guy and this guy. Not this guy, that's a solid. And then this compound. And that's over here. This is our complete ionic equation. And now we'll cross out like terms on either side. So nitrate goes out. Sodium goes out. And what we're left is 3 silver ions plus a phosphate ion yields silver phosphate. And that's what we have here, our net ionic equation.